now. Like he has a tennis racket and everything.
No, his dad plays tennis.
Marisol, don't.
He gets lots of stuff.
Who's that that plays tennis?
Carter's dad.
Who?
Carter.
Who's Carter's? Carter who?
Katase. He's not ours, but his dad's pretty good.
It's all relative. Okay. Oh, very good. 7, 9, and 11. No! Number 7. If you don't know, did you guys do long division? And it didn't come out. Didn't I teach you long division on Friday?
Not when you have to do it twice.
You mean synthetic division?
Keep going.
Okay, let's just do it. Number 7. 3x to the 4 minus 2x cubed minus 5x squared minus 8x plus 7. Divide that by x squared minus 3x plus 2. I'm doing it already. X squared goes into that how many times? 3x squared. Multiply that times the divisor. 3x to the 4 minus 9x cubed plus 6x squared. Subtract. 7x cubed minus 11x squared minus 8x plus 7. X squared goes into that how many times? 7x. Multiply that times the divisor. 7x cubed minus 21x squared plus 14x. Subtract. 10x squared minus 22x plus 7. X squared goes into that how many times?
10.
So 10. Multiply that times the divisor. 10x squared minus 30x plus 20. Subtract. 8x minus 13. And when the degree of this is smaller than the divisor, that's the remainder. So your answer is the quotient plus the remainder over the divisor. Like that, just long division.
How do you do synthetic division?
That's what I said! That's what I was saying! Okay, is there a way to do synthetic division? Because some of you might have noticed that, hey, isn't that the same as x minus 1 times x minus 2?
Yeah.
Oh, so maybe I can do synthetic division with 1 and then 2. Yes, you can, but you gotta know what you're doing. Did anybody figure it out? Somebody had a question over there? No. Did anybody figure it out?
I did it that way, but I didn't know how to get the remainder.
Exactly. Exactly, that's why I put this problem on. Nobody figured it out. Nobody noticed that that was x minus 1, x minus 2.
Or I did it that way, but remainder. Yeah.
Okay, here we go. So let's do the synthetic division. So 3. See, that's why you can't just memorize stuff. Oh, what the heck is this chop? 3, negative 2, negative 5, negative 8, 7. Okay, so we do synthetic division by, which one you want to do first, the 1 or the 2? 1, because 1 comes before 2.
Sure.
Okay, whatever. So 3, I'm assuming we all are adept at synthetic division now?
Yeah.
3, 3, 1, 1, negative 4, negative 4, negative 12, negative 12, negative 5. Did I do that correctly? Of course, I'm the teacher. Now, okay, but you gotta understand what this means though. What does this mean? If I divide this by x minus 1, you're gonna get this, you get the quotient, plus the remainder over the divisor. Right? So I'll even write, I mean, when you just do it, you're not gonna write it out, but just to help you understand. So what does this stand for? If I divide this by x minus 1, you're going to get the quotient, which is 3x cubed plus x squared minus 4x minus 12 plus the remainder over the divisor. Now I'm going to divide that by x minus 2. So I'll put 2 in the box. So 3, 6, 7, 14, 10, 20, 8. Okay, so if I were to divide this whole thing by x minus 2, that's what I just did here. Okay, so what? No, you know what? I didn't divide this part. I only divided that part by x minus 2. That's a a mistake. Okay, what do you get? What does this stand for? 3x squared plus 7x plus 10. Hey, Mr. Park, that's the same thing as this. Yeah, but what about the remainder part? That's why you gotta understand what you're doing. When you do synthetic division by x minus 1, you get this, right? Now, when I divide that part by x minus 2, what do you get? You get this plus the quotient, I mean the remainder. The remainder is a over the divisor, which is x minus 2. However, this thing got to be divided by x minus 2 as well, so it's going to be plus negative 5 over x minus 1 times x minus 2. You get it? Because you're dividing the whole thing by x minus 2. So, if you were to make a least common denominator for this, you would get x minus 1 times x minus 2, and then in the numerator you would have, what's going to be in the top? 8x, minus 8 minus 5, which simplifies to 8x minus 13. Woohoo! So that's why I told you, if you guys don't, if you can't figure out how, if you can use synthetic division or not, what did I tell you? Just do long division and nobody gets
So
hurt.
on a test, you won't be able to do synthetic division for them.
Oh, well, since you mentioned that,
Oh God.
maybe I should. No, I won't. I won't. Okay, next, number, what did we just do? 7. Number 9. Okay, this problem is super simple, you know. Okay, number 9. You have a polynomial. If I divide that by 2x plus 1, what do you get? What do you get when you divide a polynomial by another polynomial? You get the quotient plus the remainder over the divisor, right? What's the quotient? Do I tell you what the quotient is? Yep, right here. You get the quotient plus the remainder over the divisor. What is the divisor? Right there, 2x plus 1. So let me ask you this. You have to find what p is. What do I have to do to figure out what p is? Multiply both sides by 2x plus 1. That's all you gotta do. Multiply both sides by 2x plus 1 and the rest here. Can you guys take it from there?
Oh, really? I thought,
That's like, wait, because look, how do you solve for, how do you get rid of 2x plus 1 in the denominator? Multiply both sides by 2x plus 1, right? Okay, here we go. Multiply both sides by 2x plus 1, like this. Okay, so if I multiply 2x plus 1 times this, they cancel out, you get p. That's what we're trying to find, right? P. Okay, now how do I multiply 2x plus 1 times this? Well, you can distribute. What do you want to do? Okay, what is 2x plus 1 times that? Oh boy. 2x cubed plus x squared. Now go 2x plus 1 times this. It's called the distributive property, people.
2x squared.
Minus 2x squared minus x. Now go 2x plus 1 times that. Plus 8x plus 4. And then when you multiply 2x plus 1 times this, they cancel out, you just get 3. And then can you simplify that? Okay, so. Okay, that's number 7. And then number, what drawing is that? What is that? Is that a shark and a pig? Okay, don't answer me. Number 11. Yeah, how come you could do 10 but not 11? That is so bizarre. Okay, so let's do synthetic division. 1, negative 2, 1. Now notice that there's no x term. You got to put a 0 there. Or was that the problem? You forgot to put the 0. Okay, don't answer. Now, how many roots does this equation have? If it's x to the 4? It has 4 roots. What guarantees that again? What? The fundamental theorem of algebra. So there are 4 roots. 1, 2, 3, 4. I gave you 2 of them. Negative 1 and 2. You just got to find the other 2. Well, if negative 1 is a root, what do I put in the box? No, negative 1. I did this problem for you last week. Remember? Because, okay, when you do synthetic division, you're dividing by x minus the number in the box. What is x minus -1? X plus 1. Anyway, if -1 is a root, doesn't that mean x plus 1 is going to be one of the factors? If 2 is a root, x minus 2 is going to be another factor, right? The hard part is, how do you figure out what the other factor is? Remember, I told you, this is what synthetic division is for. We use it to factor polynomials so we can solve equations. So anyway, drop the 1 down, -1, -3, 3, 4, -4, -4, 4, 0. See? X minus -1 is one of the factors. What's the other factor?
2.
No, this. But I already told you x equal 2 is another root. So what do? I do synthetic division again, and what do I put in the box? 2. So drop the 1 down, 2, -1, -2, 2, 4, 0. The remainder better come out to 0. See? And that's why x minus 2 is the other factor. And what's the other factor going to be? You look at the depressed coefficients, and what is that? X squared minus x plus 2 equals 0. Now, can I factor that, or do I have to use quadratic formula? You have to use quadratic formula. I think you guys can handle that, yeah? See, once you get the remainder 0 here, then when you try the next number, you just do synthetic division of this part, right? I'm sure you guys did this last year, yeah? Okay, tonight's homework, all we're doing, oh, wait a minute. I'm just curious about last night's homework. How did you guys do number 1? Did you plug in -3, or did you do synthetic division with -3 and use the remainder theorem? Okay, okay, and then let me ask you this. What about number 2? See, okay, how many people did synthetic division on number 2? Okay, we're not understanding the remainder theorem then. Okay, let's do number 2. Synthetic division isn't always the fastest, you know. Okay, number 2. And just because you get the problem right, that doesn't mean you're doing it in the best way, you know. It says, if 2 is a 0 of this polynomial, find the value. Okay, yes, you can do synthetic division, and if you put 2 in the box, the remainder got to come out 0, right? But instead of doing synthetic division, why not just plug in 2? Because when you do synthetic division, the remainder is the same thing as plugging into 2, remember? So you just got to ask yourself, which one is faster? Is it faster to do synthetic division? Or is it fast? Here, this is what synthetic division looks like. 3, 0, k, -2. And what is the 0? 2. So you do synthetic division with 2. So 3, 6, 6, 12, k plus 12, 2k plus 24, 2k, well that's not 24, fool. 2k plus 22. That's the remainder, and the remainder has to be 0. Therefore, 2k got to equal -22, k got to equal -11. Right? I mean, that doesn't take that long. But remember, the remainder theorem says the remainder is the same thing as taking the 2 and just plugging it in. If I plug in 2 here, look, what is 2 cubed times 3?
4.
Plug in 2. 2k minus 2, I want that equal to 0, then now you're down at that step already. Isn't it way faster? That's the remainder theorem. And then also, what about number 8? Number 8. Number 8. How many of you did synthetic division? But they got 101 things.
We just skip all the zeros.
Okay, let me ask you this. What if they don't have plenty zeros? Like on the next quiz. See, you got plenty zeros, right? But what if there aren't plenty zeros? That's why we use the remainder theorem. Okay, let's do number 8. X to the 100 minus 4x to the 99 plus 3. How do you determine whether x minus 1 or x plus 1 is a factor? Well, if you do synthetic division, the remainder gotta come out 0. But why do I want to do synthetic division when I can just plug in the number? So take 1, plug it in here. You can just do it. So if I plug in 1 for x, what do you get? Plug in 1 for x. You get 1 minus 4 plus 3. That comes out 0, so yes, that's a factor. The remainder is the same thing as plugging in the number. That's the remainder theorem. You have to ask yourself which one is going to be faster. Okay, what about negative 1? If I plug in negative 1, you get 1 plus 4 plus 3. Does that come out to 0? No, therefore that one is not a factor. Now do you understand the remainder theorem? Okay, today what we're learning how to graph polynomials. Now every year students seem to remember, so shouldn't be a problem. Okay, now we're just sketching now. We're just sketching. Okay, graph this. Y equal x plus 2, x minus 1, x minus 3. Okay, when you graph polynomials or pretty much any graph, you look at the x-intercepts and you look at the y-intercepts, right? What are the, if it's in factored form, the x-intercepts are easy, right? What are the x-intercepts? Negative 2, 1, and 3. Who's saying positive? Lee? If somebody asks you how old you are, positive 16. Nobody says that. What is the y-intercept? How do you figure out y-intercept? You plug in 0 for x. Hopefully we can do this mentally. And when I say mentally, I mean in your head.
6.
Not kukuli. 6 or negative 6?
6.
Okay.
Positive 6.
I didn't say that.
Remember I told you, unless otherwise indicated, each hash mark is 1 unit, right? Okay, now, do you guys remember the end behavior that you guys learned last year? Okay, what is the degree of this polynomial? 3. Degree means the highest power. If you multiply it out everything, the first term would be x cubed, right? Is the leading coefficient positive or negative?
Positive.
Positive, so the end behavior is going to be like this, right? So if you have an odd degree polynomial, is what we have here, then either it's going to be like this or like this, the end behavior. If the leading coefficient is positive, it's like this. If the leading coefficient is negative, it's like that. Does this sound familiar?
Yeah.
If you have an even degree polynomial, and the leading coefficient is positive, then the end behavior is like that. If the leading coefficient negative, then it's like that. Didn't Mr. Takehisa do the dance of the polynomials? Like this. Right? The dance of the polynomials. Yes, he always does that. See, like right here. See, somebody remembered it. See, it says, look. Somebody sent me this Christmas card. Do the polynomial dance, Claus. Strike 3. And then Santa Claus is like this. Somebody made me that Christmas card. Anyway, so this is odd degree polynomial, leading coefficient positive, so end behavior like this. So that means I'm going to start down here. What do? Go through or bounce off? How do you tell if you go through the x-intercept or bounce off?
When you bounce off, it's because it's sort of even power.
Yeah, so when you have an odd power on the factor, you go through the x-intercept. You have an even power, the thing bounces off. Does that sound familiar? It doesn't matter, I'm teaching you like you don't know anything anyway, right? Go through. That's because negative 2 came from this factor, odd power. In fact, they all have odd power, so they're going to go through every single x-intercept. Go through. That's what the graph looks like. We're just drawing a sketch. Now, we don't know exactly how high this is. Remember, this is called a local maximum. This is called a local minimum. True or false? The local minimum here is going to occur halfway between those two x-intercepts.
Not sure.
That's false. That only works if it's a parabola, quadratic. Once you get to cubic functions and higher, no. It'll be close to halfway in between, but it's not going to be exactly halfway in between. So we're just drawing a sketch. Okay? And then over here, that maximum point is going to occur halfway in between. No, it's going to be somewhere near it, but not halfway. If you're going to eat, no crinkling. So you guys understand that? So you should be able to draw a graph like this in like 10 seconds. Okay, let's look at another one. Y equal x plus 2, x minus 1, x minus 3. Let's put an even power on one of these. Which one? Tell me when to stop.
One.
Okay. Okay, are the x-intercepts still negative 2, 1, and 3?
No.
Who said no? Go to your room. Yes, because look, it's in factored form. Those tell you the x-intercept, right? What about the y-intercept? Is it still 6? Who said yes? Go to your room.
Negative.
It is 6.
It's negative.
Okay, let's plug in 0 for x and find out. If I plug in 0 for x, you get 2 times negative 1 squared, which is 1, times negative 3. I think that's negative 6. 1, 2, 3, 4, 5, 6. What degree is this polynomial? It's 4. If you multiply out, look, 1 times 2 times, 1, 2, and 1, add them up, you get 4, right? And the leading coefficient's positive, so what's the end behavior going to be? Shoot. Okay, so it's going to start up here. Okay, what do I do? Go through or bounce off? You go through. Okay, now what? Coming up. This one bounces off. And that one you go through.
Oh yeah.
So easy. Ridiculous. Oh, you guys think you're good then? Y equal x plus 2, x minus 1, x minus 3. Okay, let's put a square on one and a cube on the other. Which one you want to put the cube on?
Right there.
This one. And put the square on
First one.
first one? It doesn't matter, this is just an example. Are the x-intercepts still negative 2, 1, and 3?
Yes.
Yes. What about the y-intercept? Let's see if we can do this in our head.
12.
12 or negative 12?
12.
Okay. So, you know, instead of going 12 hash marks, this is what I like to do. 12. But it's up to you, I don't care what you want to do. Okay, what is the degree? Let's put a negative sign in front. No, I already did it because that's going to change the y-intercept. Let's just keep it then. What is the degree of this polynomial?
6.
It's 6. It's even. So that means,
W.
what? No, who said W? No, it's how? No. Okay, now let's finish graph. And if it's not a W, you're grounded this weekend. How? Where do you get that from? You guys learned that last year? W? That doesn't surprise me. Okay, it's like this. That's just the outside. How do you know what's going to happen on the inside? Exactly, you don't know. Okay, so we know the end behavior is like this. Okay, go through or bounce off. Okay, then I need more space. Start over. Bounce off. Oh, I don't like that sound. Okay, now what? Okay, but when you go through, watch. Go through or bounce off? Through. I guess it's kind of like a W. But what if the degree was higher? What if it was degree 8 and had more x-intercepts and stuff? It ain't gonna look like no W. Wait a minute, Mr. Park. How come when it went through on this sea, like over here, it went straight through, but over here, it kind of flattened out? Exactly. You guys learned this last year, right? Because when you plug in a number that's close to 1, like 1.1, you can get a fraction. A fraction cube gets smaller, right? When you raise a fraction to a power, it gets smaller, right? So that's why it flattens out. So you have to know the difference between first, second, and third power. Now, what would happen if you had a fourth power? I'm just saying what if, but I'm not going to test you on that. If you had a fourth power on the factor, what would it do? It would bounce off, except it's going to be flatter than, you know what I'm talking about, than y equal x, when you have a square on it. What if you had a fifth power on it? Yeah, it would be like this, except it's even flatter than the third power, like that. That's because when you raise fractions to higher powers, they get smaller, closer to 0. You guys understand that? And last year, did you guys learn how to calculate local maximums and local minimums on your calculator?
Yes.
Okay, let's review that. Okay, take out your graphing calculator. Oh, I thought we were going to finish early. I thought this week we could finish early and then we can watch home videos and things like that. So we've only got 10 minutes left in class. Maybe tomorrow we can finish early. Okay, so first of all, punch this on your calculator and then graph it. So if you're in a TI, I think a zoom standard would be good. Because you want to see like all the important parts of the graph. That's one of the skills you have to have in calculus. You have to be able to graph any function on an arbitrary window. That means it shows you all the important things. X-intercept, Y-intercept, local max, local min. Zoom standard. TI people, whenever you graph, you should always go zoom standard first because you don't know what the previous window was, right? And then on top of that, zoom standard sets everything back to the default settings. Okay, there you go. Zoom standard. Everybody got it? What about the Casio people? Okay, how do you calculate this local maximum up here? TI people, you go second calculate. What do you think?
Minimum.
No, that's a minimum point up here.
Oh,
That's a maximum point. You select maximum, then it says left bound. Move the cursor somewhere to the left of that point. Press enter. Then it says right bound. Move the cursor somewhere to the right of that point. Then it says guess. Do not guess, just press enter again, and boom, the calculator will give you the coordinates of that maximum point correct to 5 decimal places. So what do you got for this local maximum here? What do you got?
Negative
0.786, comma,
8.2.
8.20.
2 to 1.
9. Come on, calculator is always 3 decimal places. You gotta get into the habit because that's how it is in calculus. Did everybody get that? Casio people, how do you calculate the maximum?
G-solve.
G-solve maximum. And the thing will calculate the first maximum. And if you have more maximums, you just hit the right what do you call that, right arrow, and then the thing will calculate the next one, yeah? Okay, practice this then. Calculate this local minimum point here. So TI, it's easier on the Casio. TI people, second calculate minimum. Left bound, move the cursor to the left, enter. Right bound, move it somewhere to the right, enter. Guess, enter. Boom, spit out that thing. What do you got?
2.1.
2.1. Well, come on, give me 3. It's automatic 3. 2.120, comma.
Negative 4.061.
Okay, everybody got that? Yeah. See how it's kind of close? It's almost halfway in between, but not exactly, yeah? Because halfway in between 1 and 3 is 2. So it's going to be near the middle, but not exactly. Now, you know that Pocket Cast that I had you guys, that app I had you download? If you graph this is even easier than the 2 graphing calculators. You know how you calculate the max and the min? You just take your finger and do this. Woo. And the thing spits out the maximum. If you want the minimum, just do this. Woo. You want the X-intercept? Woo. That's how easy it is on the Pocket Cast. Why don't we use that instead, Mr. Park? Because it's not allowed on the SAT and it's not allowed on the AP exam. That's why. So you have to learn. Of course, when you do your homework, if you want to use the Pocket Cast, you can. It's a lot faster, right? But then you gotta be practiced on your graphing calculator because that's what on my quiz, you're not gonna get to use the Pocket Cast. Okay, and then of course for understanding, this is number 1 on the next quiz, which will be
Tomorrow.
Wednesday. Oh, you want to have a quiz tomorrow? Quiz tomorrow. Why would I give a quiz in just one section? I give you the graph. In fact, several of tonight's homework problems, I give you the graph. You have to write the equation. So, write the equation of this graph. Okay, so, shh.
Yours?
Shh. And then here's the point 0, 12. Write the equation of this polynomial function. This is number 1 in the next quiz, Wednesday, right here. So first start by writing y equal, not 0 equal, y, because every year there's people putting equal 0. No, it's y equal. And then what are the x-intercepts? If the x-intercept is -3, what do I write?
X plus 1.
X plus 3, and then
X plus
x plus 1, x minus 2, x minus 4. How many points do I get for that, Mr. Park?
What?
Nothing. You don't get anything for that. Come on. Okay, now for the powers. Now you get point. What kind of power is going to be on this one? You go straight through. Okay, that one bounces off.
2.
Is it 2 or 4? Well, I told you in this class you're only responsible for 1, 2, or 3. Okay, I'm not going to give you 4 or 5. You guys know though. So 2. What about on this one? 3. And then what about on that one? Bounce up. 2. Woo!
Negative. So negative.
Okay, if you just wrote that, if this problem is worth 4 points, you just got 2 points. That's the answer, Mr. Park. Don't be ridiculous. How do you know the coefficient here is 1? Okay, now, if you put negative, I give you 1 more point. You get 3 out of 4. But how do you know it's -1? How do you know it's not like -3 or -1/4? How do you know it's -1? That's why you should just put A here. You don't know what that number is. How do I figure out what that number is? You plug in a point that you know. That's why he gave you that point right there, 0, 12. So plug in 0 for x and 12 for y. Go. 12 equals A times plug in 0.
4.
What?
Oh, 3.
0 plus
Oh my god.
3
3.
times 1 times -8 times 16. Did I do that correctly? Oh boy, so therefore A equals 12 over 3 times -8 times 16. Let the canceling begin. 3 goes into 12, 4. 4 goes into 16, 4. So therefore A is -1 over 32. So all you have to do is put -1 over 32 there, and that's your answer. Yeah, you know it's negative, but you don't know if it's -1 or negative. That's how you figure out the exact one. See how this is pretty easy, you gotta admit. Okay, so tonight I'm not gonna reduce the homework because this is just too easy. Now when you graph, I don't want you to make a masterpiece, okay? Like for example, here, I'll do 1b for you. Okay? Y equal x squared times x. It says check on your graphing calculator, but these are so easy you don't even have to check. X-intercept. Maybe you do need to check. 0 and -2. True or false? If the x-intercept is 0, the y-intercept is also 0. True or false?
True.
True, because this is a function, right? Okay, degree 3, leading coefficient positive. It's going to look like this. So, no, you don't clap. That's what you're supposed to do. It goes through and then it bounces off, right? So this will work, come on. And then number 5. I don't want to see number 5 on the board up there. Did I teach you how to solve any equation on your calculator?
Yeah.
Yeah, what do? You make one side 0, like number 5a. No, 5b it already is. But make one side 0, you graph it, and then what do you look for? Where the thing crosses the x-axis, right? So hopefully we don't see number 5 on the board tomorrow. Anyway, if you do it on the pocket cast, look, the thing crosses, you just go doink, doink, doink. There's the 3 answers right there. You should try it. Like when you're in the bathroom the next time, you got nothing better to do than read People magazine. Do this instead. That's what I do. I take my... No, for real. You learn so much stuff. Okay, never mind. The bell's going to ring in 1.5 minutes.
People magazine.
I would say 1/4 of the learning that I do comes from being in the bathroom. I read graphing calculator manuals, I read math books. You didn't see your test? And you didn't come this morning? Strike 1! I guess that shows me how important that test was to you. Strike!